All right, let's talk about biofuels. Really, we're going to talk about how we make it and then also how we extract it. Now, bioethanol. In the previous session when we were talking about fuels, we mentioned that bioethanol was an example of a biofuel. Honestly, anything with bio in front of it, it's a biofuel. Now, when we talk about bioethanol, this comes from the fermentation of glucose. Now, how do we actually get the glucose is the great question. What we generally do is we'll pulp some carbs and with water, and so we're just squishing it. And then what that does is it breaks it down, and then we use enzymes to help us out to actually fully break that carb down into the glucose that we need. Once we do that, then we have the glucose that goes into this reaction where it undergoes fermentation with the support of enzymes. You probably think about fermentation when it comes to, like, if you've ever baked before. The reason why it rises because it interacts, like the enzyme and the yeast interact with each other, resulting in the formation of the ethanol and also the carbon dioxide. And the carbon dioxide allows that bread to actually rise. Because, as you can see from a chemical perspective, the bioethanol that comes out is in aqueous form. Now, if you want pure bioethanol, having water in there is not a great idea. And so what we'll have to do is we actually have to use heat to separate the two. Now, when we're extracting bioethanol, this is a really simple method and procedure. So say, for example, we've got this sample of, the aqueous solution of the bioethanol here. We'll use heat. But what happens is eventually at a certain point, at a certain temperature, things will start to evaporate. Now, because ethanol has a lower boiling point than water, so what will happen is the ethanol will evaporate first, okay? And then we'll go into here. It gets cooled down. Once it gets cooled down, it comes back out here as a liquid. So we collect it on the other side. We collect the pure bioethanol. So as I mentioned in the previous slide, this looks a bit more complex, but it's essentially doing the same thing. You're heating the sample, the liquid will boil, you collect the vapor, you allow it to condense back into a liquid, then you collect the liquid, and we call that liquid the distillate, right? So it's that separate liquid on the other side. Now, biogas is awesome because it's made from organic matter. That's why it's so bio. It's just stuff that you see outside. So it could be dead leaves, dead organic matter, sometimes stuff that we probably don't want to talk about. Now, it's broken down by bacteria, and what happens is, I don't know why it says SS. Let's go. It's a mixture of gases, but mainly what we're looking for within that is methane. Now, biodiesel, made by a process called esterification. You know esterification, you learned about it in year 11. Specifically, when we're talking about biodiesel, we're talking about trans esterification. So you are making esters, but it's just a unique name that we have. Now, the reason why it's so good, and we call it bio, is that it's plant-based. So you can use oils from plants like canola oil or what are the other oils, like vegetable type oils. I'm just thinking about the oils that you use to cook. You can actually use those oils to make biodiesel. And to do that, we're taking triglycerides from the oil. We react it with methanol, and what will happen is you'll get a glycerol and 3 fatty acid methyl esters, i.e. biodiesel molecules out of it. Now, you need a catalyst to support this, okay? Sometimes it's this, sometimes it's that, but you do need a catalyst to support the reaction because, as you know, catalysts speed up the rate of reaction. So the previous slide, too many words, quite confusing. What I'm going to do instead is I'm going to show you what happens during these diagrams. So the reaction itself, you can see here, this is a triglyceride. Now, each of these R's just tells you that, hey, it's a fatty acid chain. You don't have to worry about what it is for this demonstration. As you can see here, these are the ester functional groups. Ester, ester, ester. Now, this whole thing here is called a triglyceride. You react that triglyceride with some sort of alcohol. So in this example, they're using methanol. In the presence of a catalyst, what you end up having is a methyl ester. The reason why they say it's methyl, that would have come from the methanol. And the rest of it, the whole molecule itself, is actually a biodiesel molecule. So that's biodiesel, that's biodiesel, that's biodiesel. And what you also produce as a result of that is you break away the glycerol from the triglyceride. Now, the structure of glycerol is actually found in your data book, so you don't have to worry about memorizing that. This will become a lot more clear when you learn about fats a little bit later on in the unit. Okay, so for now, it feels like you're trying to rote memorize stuff, but don't. It will make more sense when we learn about fats very soon. Okay, specifically, what does that actually look like? So you can see here, you're essentially taking this part, right? Really, because they're individual parts. So this part of the triglyceride, you're combining that with the methyl part of the methanol. So if it's methanol, it's the methyl part. If it's ethanol, it's the ethyl part, right? Together, they'll combine and produce each of our methyl esters, which is our biodiesel molecules. Then what will happen is this guy and this part of the alcohol will join together and reform our glycerol molecule. Okay? Now, so again, let's just summarize what we just saw. The fatty acids from the triglycerides will break off. It will react with methanol, for example, or ethanol, and what will happen is you'll get the methyl esters, which we call biodiesel. The reason why we call it a methyl ester is because we're using methanol, and it is an ester. If it was ethanol, we'd call it an ethyl ester, but whatever, okay? Usually it's methanol. So the remaining hydrogen and the triglyceride, or whatever's left over, will form your original glycerol molecules. Cool? So, in summary, in terms of how we make each of these, bioethanol, fermentation. Then we can use distillation to separate it. In fact, we can actually use fractional distillation for fossil fuels as well, but I haven't spoken about it here. Biogas, methane. Bacterial decomposition from organic stuff. Biodiesel, take some plants, because you want the triglycerides out of that, react it with an alcohol in the presence of a catalyst via transesterification to get your biodiesel molecules. Cool? Awesome. Always remember, no matter what anybody says, yeah, you can.